Hi everyone, this is a question which I have created based on the questions available in the GMAT official advanced questions book. Now let's try to do this question. Miss Fair is John's class teacher. She always tries to treat everyone equally. On a certain day, many students from nearby schools visited John's school for a cultural festival. Miss Fair had certain number of chocolates which she distributed to the children equally. Was the number of chocolates received by a child within 2 of 20? Assume that a student can get a partial chocolate. Now we're given two statements. Statement 1 says the number of chocolates to the nearest 1000 is 3000. And statement 2 says the total number of children on that day to the nearest 50 is 150. Remember, this is a data sufficiency question. You don't need to find the answer. You just need to be able to choose one among the 5 options A, B, C, D, E. Choose A if you can solve this based on the information given in statement 1 alone, and choose B if statement 2 alone is sufficient. All right, and again 1 alone is not sufficient, so that's what's mentioned over here. Now if you need both the statements, then you need to choose C. Now if either of the statement alone is sufficient, then you can choose option D. And even after using both the statements, if you're not able to solve the question, you should choose option E. So that's the question. Now take a moment, pause the video, try to solve it on your own, and then let's discuss it together. Alright, we are back. I hope you have given it a try, and remember to subscribe and support this channel and hit the like button if you're liking the video. Now let's get started. Now as per the question, we need to find whether the number of chocolates received by a child is within 2 of 20. So that's what is given over here. Now within 2 of 20 means that it should be between 18 and 22, right? 20 minus 2 gives you 18 and 20 plus 2 gives you 22. So you just need to find the number of chocolates divided by the number of children, and we need to know whether that number is between 18 and 22. So that's the question. Now let's take a look at the statements given. Statement 1 says the number of chocolates to the nearest 1000 is 3000, but again we don't have any information about the number of children. And similarly, statement 2 only talks about the number of children, which is 150 to the nearest 50. Again, taking statement 2 alone gives us no information about the number of chocolates. So definitely statement 1, option A and option B are out, because we need information about both the number of chocolates and the number of children to be able to solve this. Now let's try to take both the statements together and see whether we can solve it. All right. Now the number of chocolates to the nearest 1000 is 3000. So that means the number of chocolates is between 2500 to 3500, right? So if you round 2500 to the nearest 1000, that goes to 3000, right? And similarly 3499, if you round it to the nearest 1000, that also goes to 3000. So we can say that as per statement 1, the number of chocolates is between 2500 and 3500. Similarly, as per statement 2, we can say that the number of children is 145 to 155, right? Only then if you round to the nearest 50, 145 will round to 150. Similarly, 154 will round to 150. So I'm just taking it as 155 to keep the calculation easy, right? Again, over here also it can be treated as 3499, but we are just taking 3500 to make the calculation easy. Now we need to know, in all the possible scenarios with these ranges in mind, will the number of chocolates divided by the number of children be between 18 and 22? So for this, let's find the minimum value. Again, remember we are trying to find chocolates divided by children. So we want to find the minimum possible of this ratio and the maximum possible of this ratio to know whether we can even find whether definitely it's going to be in this range or definitely it's not going to be in this range. In either of those cases, if we can have a definite yes or a definite no, then the answer would be C. So let's try to find the minimum and the maximum of this ratio over here. Now to find the minimum of this, we need to have the numerator minimum and the denominator maximum. So that's when the ratio becomes minimum, right? So that would be chocolates minimum divided by children maximum. And to find the maximum of this range, again the numerator should be maximum and the denominator should be minimum, right? So that would be chocolates max divided by children min. So let's try to find these two ratios. Now chocolates min is as per this 2500, right? And children max is 155. So we have 2500 divided by 155 over here, which is the minimum possible value of this ratio. and the maximum possible is chocolate max by children min, which is 3500 divided by 145, right? So 3500 divided by 145. Now if you take a look at this ratio over here, this comes to approximately 16, right? So 2500 divided by 155 gives you approximately 16. And similarly, when you take a look at this ratio over here, 3500 divided by 145, this comes to close to 24, approximately 24. So you can see that 16 and 24, 16 is over here and 24 is over here, right? So we don't have a definite yes nor a definite no. In some cases, it's possible that the ratio comes over here, which is in between 18 and 22 or within 2 of 20. And in some cases, it can come over here or over here, which is not within 2 of 20. So we don't have a definite answer, which is yes or no. So therefore, the correct answer to this question is going to be option E. That is, we cannot solve it even if we use both statement 1 and 2. All the best in your preparation.